watch this. Cool. All right, so hey guys, thanks for coming out. This is Drexel IEEE's ECE in 60 Minutes event. So my name is Kash Thacker. I'm the academic chair for IEEE, and joining us is Juliana, and she's on the academic committee. So her and I will be kind of giving you a talk about what it means to be ECE, since I imagine some of you are freshmen here and you're kind of getting overwhelmed with your classes, and registration for next term already opened up and everything's going by so fast. So hopefully this will give you an idea of what there is in your future, like what classes you can take, where you can do research, what can you minor in. Yeah, so just looking at the polls, I think there's a pretty nice split of electrical and computer engineers. And as well as you're undecided, it's fine. Hey, it's maybe freshman year, you have plenty of time to declare a major. But hopefully this presentation will get you to lean towards electrical computer engineering. So why are you here, first off? Like, what does it mean to be an ECE? So we're in everywhere you can think of. We have like, our fields are everywhere from robotics to computer chips to renewable energy in the power industry, the cybersecurity. Medicine today is not possible without our advancements in the biomedical imaging and the digital signal processing industries. This is what we do. And this is what you guys will be doing. Hopefully some of this, what I'm talking about, the research that our professors here at Drexel are doing, interests you and says, wow, and tells you that, wow, I want to do this for a living, or I want to do something close to this. So that's us. So some of the programs, how many of you guys know about the BSMS plan before coming to Drexel? Well, when I came to Drexel, okay, thanks for raising your hand. It's a very amazing program. You get your bachelor's and a master's in 5 years. In master's within anything you want to do. The typical norm is either within the department is computer engineering, cybersecurity, electrical engineering, there's electrical and telecommunications. And for new this year is a machine learning engineering master's, where you concentrate in signals and more on the side of neural networks and that kind of stuff. And there, as well as a robotics master. So the research that we have, one of the amazing opportunities in the research is something called VIP, which stands for Vertically Integrated Projects. For you freshmen, I think Dr. Dondiker, who's the lead of the undergraduate research or of the research for this program, he'll send out an email about this stuff within the next coming weeks. And what it is you apply for an undergraduate position with a professor researching a certain topic. And if you get accepted, if you like what you're doing, you get accepted and you like what you're doing, you can continue doing that research throughout multiple terms through your undergrad career, which is a great opportunity. And we'll talk about some of the projects that professors are doing in future slides. Cool. Julianne, you want to talk about the minors available?
Yeah, I can do this. So there's a couple different minor options you can do if you don't want to do a whole extra degree or anything. Minors are usually 24 credits. Depending on your program, some colleges only allow like 8 to 9 credits of overlap. Others will allow you to fully overlap the minor. It just kind of depends on what you're doing. So within the department, there's 3, obviously electrical and computer engineering, and then we have nuclear engineering. One note, if you're not a freshman, you can probably fit the entire nuclear engineering minor in with your elective credits. They kind of reworked a lot of the program for people who are entering this year, and we'll touch on that later, but you can't quite do that this year, but you can just take a couple extra classes. You do other things within the College of Engineering, everything except civil, you could minor in as other things as well. For example, I just picked up the Green Energy and Sustainability minor. You can also do robotics and automation, systems engineering, all of the funky little engineering management type minors. So there's all that stuff. If you want to go outside the college, you can. There's a whole bunch of things in CCI you could do depending on what you're interested in. And then for other things, you could do an entrepreneurship minor. I know a lot of us get those emails about the math minor saying like, oh, you've already completed like X many credits, like you're a good candidate or whatever. So depending on how many math classes you have to take for your major, it won't be that many more for the math minor. It's up to you. Project management is not currently accepting applications, but that could change, who knows. Do something in Labo, or you can also do whatever you want. I'm also a history minor just because I love history. So if you're like a freshman and you just want to minor in something random, like that's also totally fine.
So now we're going to dive into some of the specific courses. So for specific specializations, so with the power, computer,
Your audio is weird.
Yeah, no problem. I can take over while he figures that out. So the second half of this presentation is mostly devoted to the different tracks within ECE. Unlike other majors, we don't have like declared concentrations or declared tracks. Like you would get your degree and it just says EE or CE and that's that. But there are different types of courses and different things you can concentrate on within ECE if you choose to. That's kind of what we're going to dive into here. Akash, if you want to go to the next. There you go. So just some intro courses. So this is fundamentals. There are some very basic courses that you'll take mostly freshman and sophomore year. That's those first four. And then there's other courses you could take depending on some of the three major tracks, ECEC, and then the E and P tracks. And we'll get into those later. These are basically the first classes you would take to kind of explore those tracks. If you want to, you'll notice a bunch of them have asterisks. Like this is at the bottom, we reworked a lot of the classes for this academic year. So the department expanded the core. So you'll take a lot more classes that would expose you to different types of things before diving into electives. And they kind of shrunk the number of electives just so people could get a broader base before branching off into something specific. So again, these are just kind of the first couple classes that you would take for different tracks and stuff. So the power courses, Akash and I went back and forth. We kind of ended up just basically putting like every single course that is offered for these tracks on the slides. So that's why there's a ton of courses on here. The first two, you saw one of them on the last slide, are kind of the intro courses. There used to be an ECEP 354. That's mostly been replaced by ECE 380, which is this year. A little bit of it is in 411, but it's still kind of covered. Those are the two basic classes, and then there's all different sequences you could take. There's the power system sequence, there's the electronic converter sequence. There's also two renewable energy courses. So I am actually in 380 right now, which is Intro to Renewable Energy, and 480 is offered next term, but it is tragically already completely full. So I possibly will not get in. We will see. And then there's some nuclear engineering courses. Most of these line up with a nuclear engineering minor, or you could just take them if you're interested in nuclear engineering stuff. So yeah, it's kind of the courses that would be offered basically with P at the end of them and what they're about.
Quick question, sorry.
Mm-hmm.
Could you go back one slide a second? So I'm taking 380 with you, by the way. Am I like, do you have to concentrate on like either like power electronic converters, for example, or nuclear engineering, or could you take like a mix of classes from both?
You can take a mix. So there's a couple requirements in terms of like degree work. So you have to have like whatever, like 9 credits of 400 level classes or something. But because ECE doesn't do any sort of declared tracks, you can really mix up whatever you want. We just broke them into this. So if you were interested in something, you could see what goes with what, but you don't have to officially only take classes in a certain grouping.
Oh, okay. So if I need like 4, sorry, is my audio working?
I can hear you.
So if I need to take like 400 level, it could be like a mix of P and E and C.
Yeah, it should be, I think it's 400 level. So you could totally take a sequence. Like if you wanted to take like the power electron converter sequence, you could, and you can also pick and choose what you want. So it is up to you.
All right, thank you.
Yep, no problem. All right, we can go on to research if there's no more questions about classes. So there's some research. You'll see at the very end of this presentation where we got all this information from. So we do like have sources, but there's sort of 3 research areas. There's alternative energy, which is Dr. Scholes, who's teaching 380 right now, that I actually look like a couple of us are in. There's nuclear engineering, which is 100% Dr. Peters' wheelhouse. And then there's power engineering and smart grid, and that's Drs. Mew and Niebuhr. Niebuhr also teaches that 411, 412, and 413 power systems course this year. There's 3 different labs. I would recommend checking out that middle one. The EPEC actually has its own website. If you're interested to really look more into it, they have a bunch of different archives with old projects and stuff like that. So they have their whole own website with tons of information on it. And then application areas, there is an application areas sheet on A4E in BB Learn and advising for engineers, and it lists different application areas. So that's where you'll see we drew these from. The main application area for these kind of courses or this kind of research would be electric power and energy. Any questions on any ECEP related stuff? All right, cool. Akash, if you're good to go, you could take the next set.
Sorry, I just have a quick question. Is there a way that could help us figure out like which concentration and power we want to pursue, like if I'm not really sure?
I mean, yeah, so you could, there's different ways you could talk to professors. So if if you're in 380 right now, you could talk to Scholes and see what he has to say. You could try taking one class in each of the sections. So like if you, I don't know, like if you were interested in nuclear engineering, you could try taking one of those first couple nuclear engineering-ish courses and see if you like it. I kind of wanted to give this presentation to give you guys an overview of what's out there. And if you know what you're interested in, maybe you'll know what classes to take, but also a lot of it would just kind of come down to yourself, maybe a little bit of trial and error, a little bit of experimentation to see if there's certain classes or professors you really jive with. You can also like just kind of look up what you would do if you were to go into that part of the field or something and see if that's something that you think you're interested in. Or if you have co-op experience that could inform that decision, you can always lean on that as well.
Yeah, sure. Makes sense.
Yeah, I'm sorry if that wasn't like super helpful.
No, it was. Thank you.
Cool. Is my audio better now?
No.
All right, I can keep going until you get that figured out. Although full disclosure, Akash did do the slides for the other tracks. So he definitely would be a little better at these. Okay, cool. So this is the computers track. We'll just go until Akash gets this figured out, but that's what the C stands for. You can see again, there's intro classes, and then there's, again, we broke these up into different sort of themes, but you can mix and match. One thing I guess I forgot to mention is that there are prereq chains, so you can mix and match to the extent that you meet the prereqs, but you can't just hop into like a high level class for a totally different track if you might not have the prereqs for that. So yeah, these are some of the different options. Again, Akash would be able to talk much better on this. So hopefully he can do that.
I think I got it. Is it better now?
Sounds good. It sounds good to me.
Okay, cool. Sorry about that. I don't know what was going on with my microphone there, but so this is for all my computer engineers out there. ECEC, so the introductory courses for in the computers track, I guess you could say, is advanced programming for engineers, which is C programming. I think who teaches it now is Dr. Shackelford, and he's amazing. He's an amazing professor. And as well as ECC 204, which is microcontrollers. So that takes you into using C to write software to control a microcontroller, which I think between the combination of those two will help you determine whether you want to go into whether computers is something you want to do. And then on the other side, there are like the four big areas in computers. In ECEC is computer architecture, who Dr. Das is the main expert with this stuff. He teaches 355 and 412 and 413. 412, and then Dr. Kandasamy teaches 413, if I'm not mistaken, which are just about how everything works at a computer level, how the CPU interacts with the memory and the cache and how instructions are deciphered by the CPU. Then operating systems is ECEC 355 or 353 and 421 and 422. I'm taking 353 next term, so if anyone's taking it with me, see you in the class. And then VLSI and ASIC design, which is more along the lines of hardware, simulating the NMOS, PMOS transistors. And I haven't taken it yet, but from what I hear, it's a very intensive class with Dr. Savitas and very thorough. So if that's something that interests you, it's a very good field to go into, as well as digital systems. So Dr. Prawat teaches these courses, which is ECC 302 and 402. And it's more along the lines of similar to 204. It's more about how you can write software to interact with hardware and more about the embedded side of things. So if that's something that interests you, Dr. Nagravajara is a very good professor with that. So for research, there's a lot of opportunities for this stuff. So circuit design with the following, Dr. Gerber, Savitas, Scholes, and Taskin. I believe Dr. Savitas does circuit design with security of a hardware, like how can you make a hardware chip more secure, I think is his latest research. Then computer architecture with Dr. Kandasamy, Nagravajara, Taskin, and Trachtenberg, as well as VLSI with Dr. Savitas, and wireless communications. So Dr. Dondiger is the head of the Drexel Wireless Systems Lab. And in that, you do a lot of RF stuff, or RF manipulation. We have a mesh of Dragon radio set up in the lab that you interact with and simulate different situations. So the research labs that you can apply to or look into are listed there. I think the most common ones are the most famous ones right now are the VLSI and the DWSL. And application areas, as far as that goes, IoT is huge right now, as well as computer system design and embedded systems. And if you want to go into more hardware side of things, the processor and chip design through the VLSI and ASIC courses. Are there any questions about ECEC classes or research before I move on to the next one? Cool. So ECEE courses are electronics courses about how electronics actually work. So the introductory course for these, for the ECEE courses is ECE 370, which is taught by Dr. Navet, and goes into how a transistor works and how, like what the physics behind this stuff is. And if that's something that interests you, he dives into it deeper with into semiconductor devices with analog electronics and the 421, 422 series that dives even deeper into the different types of electrical components and how they're used in circuits. And then on the flip side, if you like more, if you're interested in the wireless devices with RF or optics, the 354, which is wireless optical devices, is for you, as well as the RF series, which is 471 and 472. So the research for that is similar to, or for the first one is similar to the computers, the circuit design, because you can't make a circuit without having both some software and some hardware. And so there's also electro-optics, which Dr. Fontecchio and Dr. Dariush lead right now, as well as flexible electronics and nano electronics, which is flexible electronics is more about how you can incorporate electronic equipment onto the human body. So like in adding, I know Dr. Doniger is working on like a belly band that you can wear around your waist and track the movements like in your belly, and it's pretty cool stuff what goes on with his lab. So in the same lab, there's also RF and antenna design, where they design different types of antennas and just test them to make sure they're efficient, as well as telecommunications and wireless communications. So I know that 5G is becoming a really huge topic right now, and I think they are doing good research with that in the DWSL. So some application areas are the integrated IC design, so integrated circuit design, microelectronics, antenna design, and cellular communication. Yeah. Do anyone have any questions about E classes or research so far? If you have any questions, feel free to interrupt me. Cool. So the last specialization is systems. So this is for people that, for like the people that love math. So introductory courses for this is Signals 1, which is mandatory for both electrical and computer engineers. Signals 1 is purely math. It's about how you can decipher a signal in time domain and convert it to frequency domain. And so like take a signal that's discrete, so like it has like discrete points, and convert it to a continuous signal. So it's a lot of math. It's a really math-centered discipline, I guess you could say. And then ECES 303 is Signals 2, which is required for electrical engineers and optional for computer engineers. So in the systems realm, there's communication with analog and digital communication, which is ECES 306, and wireless, mobile, and cellular communication, ECES 354. On the flip side, there's digital signal processing. I'm sure you've heard that buzzword thrown around at least once. We have a lot of good classes in that, which is like the 434, 435 sequence, 434 through 436 sequence, which just talks about advances in digital signal processing, applied digital signal processing, and multidisciplinary DSP. Lastly, the last topic is systems and controls, which is ECES 356, which talks about how theory of control and all that jazz. Yeah. So some of the research areas with signals, there's a lot. Signals is huge with robotics. If robotics is something that you're interested in, signals is going to be, I think, at the core of your curriculum. So some of the application areas or research areas is adaptive signal processing with Dr. Rosen and Walsh, biomedical engineering with Dr. Cohen and Dariush and Dr. Shackelford, controls and robotics with Dr. Chmielewski and Dr. Guiz, Kalada, and Kim, digital signals processing with those professors. And you can just see there's a lot of different research opportunities available if you're interested in signal or systems and signals realm. The labs that do this are again the adaptive signal processing, Drexel Wireless Systems Lab. Again, this lab keeps popping up, but I feel like they're so diverse, or they do such multidisciplinary work that you can find if interested, you can find a role or a niche to fill in that lab. But the application areas, wireless systems, audio signals, image analysis, sensors, biomedical applications, and again, digital signal processing. So any questions on signals and systems classes or areas, research areas? Cool. So I think that concludes okay. Juliana?
Yeah, this is like a secret bonus track. It's only for graduate courses, and I know little about this and do not plan to go into it, but we figured we'd throw it on here just so that you guys are aware of it. If you've ever looked in the course catalog, you'll see that there's the ECET like course identifier number. That's the telecommunication stuff. If you remember from the very beginning, Akash mentioned that one of the master's options is like electrical and telecommunications engineering, and it draws on a lot of this stuff. So if you're interested in this, again, we only really offer the classes at the graduate level. Honestly, I don't actually know what the special topics marker is. I think that's when the T is at the front of the numbers and it's not at the end of the letters, if that makes sense, right? So if you were to put the T with numbers section of the course like identifier, then it's the special topics, but when the T is at the end of the letters, that makes it telecommunications. Cool. So yeah, these are some of the classes. If you were interested in this, I'd recommend talking to professors. If you go to the next slide, Akash can show you the labs that are involved with it. Just because since there isn't really that undergraduate exposure, you'd kind of have to figure out if you want to go into this for your master's. A lot of the same stuff that you'll see with other tracks, especially like the systems track. So yeah, this one is kind of like a weird other. If anyone here has taken these classes or is mastering in this, you can feel free to drop some information. But it is out there if you think you could one day be interested in it. And then I would just want to mention this real quick. This is like partially like our works cited slide in case you think we're lying to you, but also it's just a little compilation of resources, everything that we referenced. A4E in BB Learn is very helpful. They have a lot of stuff just kind of compiled there. If you've ever seen that flowchart on Excel with the different like courses you can take, that's in there as well, as is the application guides. There's some information about telecommunication stuff in the chat if anyone is interested. All the stuff about the curriculum, if you're looking to dual degree in EE and CE, I think there's a whole like plan of study in there for you, plenty of information on VIP. There's 2 links to all of the information about research, both by professor and then by laboratory, and then obviously course catalogs and WebTMS have information about the courses that are offered. So that is all in there if you guys want to go find this information yourself or look up more stuff.
Yeah, so long story short about like where all this is, A4E is going to be your best friend, especially the freshmen. You will be referencing this multiple times, whether you want to go into, whether you're just doing a normal or not normal, or you're just doing a bachelor's degree, or you're trying to do a dual degree or BSMS, you will be revisiting that multiple times throughout your Drexel career. Yeah, so this PowerPoint will be placed on the link tree, which the link tree will also have a link to this recording for this presentation, so you guys can reference all the resources and classes for the stuff. Yeah, I think this is it. If you guys have any questions about the courses or research, or just any questions, see what you want to ask me, Julia, or any of the other people in here, just unmute your microphone and ask, or you just type it in chat, whatever works for you.
I have a follow-up. So for these special topics, in my, like when I see the Excel spreadsheet, how do I know like what each special topic stands for? Is there a way I could like look into those, or?
So special topics courses, if I'm not mistaken, are announced the term before, usually, like what they'll be. I think because they fluctuate so much that they either announce them the term before or the term of. So yeah, so I think Ray said attend the ECE chat. So they talk about special topics courses, and keep an eye on your email. I know Haley sends out an email a couple weeks that has a lot of information in them, and yeah, they should have what each of the special topics courses are that are going to be offered for the upcoming term are.
Oh, sorry. Where's the ECE chat again? Is it like, are you talking about?
Yeah, so the ECE chat. No, so the ECE chat is a event that the ECE department, the advising department, holds twice a term. I forget. Is it week? Someone want to jump in the first? I forget when the first week is, but there's one coming up next Tuesday, or for the Tuesday of week 8, and I think the Thursday of week 4, if I'm not mistaken. Yeah, we usually week 3 and 8. So they have the two events. They're usually an hour long. You just go in, chat with. There's usually a bunch of professors there, and a couple people from advising are there. So you just go and chat, talk about how your classes are going, what class you're gonna be offered next term. It's a very casual, I guess, event that they hold. It's really helpful. It just kind of help you distress and talk about what's going on in your classes. But yeah, that's a really great resource to have. Cool. If you guys have any other questions, feel free to message me or stick around after. I'll be here for like next 5-10 minutes. But other than that, thank you guys for coming out. I hope you guys learned a lot of important stuff about how to navigate your ECE degree. But cool. Thank you.